section 15.4, congruent shapes. This usually means GCSE congruent triangles. Now, the best way to define congruent is absolutely identical to. And so when we're dealing with congruent triangles, we're given a pair to compare, then we need to apply certain rules, and if certain conditions are fulfilled, then the two triangles presented on the screen will be congruent. Let me give you the 4 rules. This is not in any of the exercises. So if I was given a triangle like that, and one, say, drawn like that, and I was given, for example, this, if that side corresponded to that side and they're identical length, and that side corresponded to that side of identical length, and this side corresponded to this side of corresponding identical length, then these two triangles share 3 lengths exactly the same. And if you share 3 lengths or 3 sides exactly the same, you are identical, and you are therefore congruent. And the rule for these 3 corresponding sides is called the side, side, side rule. In other words, the S, S, S rule. And that's okay. You can use that shorthand at GCSE. Now, supposing you're given a triangle like this, and a triangle like that, and you're given this angle here corresponding to that angle there, and you were given, say, this angle here corresponding to that angle there, and you're given a certain length across the bottom here, so this length is identical to that length. Would you have enough information to draw these 2 triangles, and could you confirm whether they're identical or not? Would they be congruent? The answer is yes, they would. And the rule is to have 2 angles that are corresponding angles, and they're identical in size, and the length between the 2 angles is also given to you. Had this length not been given to you, for example, you cannot say for sure that the 2 triangles on offer, I can't draw now, not responding, that the 2 triangles on offer would be absolutely congruent. In fact, they wouldn't be. Let's just pause. Right, I was trying to say, if you're given 2 triangles like this, and you weren't told that this side was identical to the length of this side, you can't assume, based on just 2 angles alone, that the triangles will be congruent, that is, identical to each other. Better just ignore that phone. Right, so if you were given this, however, as I did before I went all glitchy, if you're given 2 corresponding angles like that, and the side between the 2 corresponding angles are given to you, then these triangles will also be congruent as well, that is to say identical. But it's a different rule. Here we have the rule angle, side, angle. Look at it again, angle, side, angle. It's the A-S-A rule, okay? Alright, so angle, side, angle, that's the second one. Here's the third congruency. Again, any random triangle like this, draw it even upside down, doesn't matter. Suppose you're given an angle. So this angle, you're told, is identical to this angle here. And you're also told that this length matches that length, and that this length matches that length. The question is, can you guarantee that these 2 triangles drawn as shown are identical? Well, they will be, because look, you have a corresponding side there and there, and another corresponding side there and there, and you have an angle between them. Okay, so the angle that's between the 2 sides that appear to be corresponding, if they're the same angle and you're given the same angle, then these 2 triangles are guaranteed identical, therefore they are congruent. And that is the side, angle, side rule. Alright, now it's different to the ASA rule. It's not 2 angles with a side in between it, it's 2 sides with the angle in between the 2 sides. If you end up with this situation, then it's the SAS rule, side, angle, side, side, angle, side, and the 2 triangles are definitely congruent and identical. Now here's one that stands all alone. You're given this, and say you're given something like, I don't know, that. You're given the fact that there is a right angle present, and you're given the length of the hypotenuse, so that matches that one. Remember, the length opposite the right angle is, just get rid of that, the length opposite the right angle is the hypotenuse. So if you're given hypotenuse, pen's being silly, if you're given the hypotenuse and a right angle, and you're given one other corresponding side, let's say you're given that one, and where is the other one, say, so height goes to the bottom, and that one, then what you've got is a right angle, a hypotenuse, and another corresponding side. And there's the right angle, and the other triangle has been sort of flipped around. So they're definitely congruent. And the rule is right angle, hypotenuse, and any other corresponding side. Alright? So that's the rule. Let's put the word rule in, because this is in fact a rule. It's the RHS rule. And that stands for right angle, there you go, hypotenuse, the longest side, you've been given that, and any other corresponding side, so this one and this one, or this one and this one. You don't need all three sides, just any one of the extra corresponding sides other than the hypotenuse. So let's just review that quickly, and we'll shut off this video as an introductory thing. Right, these are the four congruences, side, side, side. If you're given two triangles drawn differently, and they've been flipped the other way around, so they look different, but if you're given three identical sides on each side, so let's give you an example of that. Let's work with blue here. If we're given, for example, 3 centimeters, 4 centimeters, 6 centimeters, and you're given a 3, 4, 6 there, even though it looks all flipped over and different and deliberately drawn wrongly and not to scale, the maths dictates that these three equivalent sides that correspond with each other produce two triangles which are identical or congruent, and they fit with the side, side, side rule. Okay. Next one. Suppose you're given this, and this was, say, 30 degrees, and this was obviously 30 degrees as well, and this one was, I don't know, 40 degrees, and this is also 40 degrees, and you're told, for example, that the length joining these two angles is 4 centimeters, say, and this is also 4 centimeters. You can see if you've got two 4 centimeter bases and you've got the angles at each corner the same, they will definitely meet at the same common point, and therefore these sides will be the same as well. But you don't need all that information. We just know that if we have two angles that correspond together and we have a length that's between the two angles, we have an angle side angle rule, and the triangles will be congruent, identical with each other. Next one, we have a shared common side, another shared common side, and one common angle which must be between the two sides, hence side angle side rule. Let's give you an example here. This could be 5 centimeters, therefore that will also be 5 centimeters. This one could be 8 centimeters, this could also be 8 centimeters, and the angle between them must be the same. So this could have been, say, 30 degrees, and this has to be 30 degrees as well. So what have we got? We've got a 5 centimeter line and an 8 centimeter line, and it spans a 30 degree angle. If it's exactly the same on the other triangle, no matter how it's drawn, whether it's been rotated or inverted or reflected, makes no difference. If you can see this congruency apply, then the two triangles are identical or congruent. So it's the side angle side rule. This one's dead easy to spot. First watch for a right angle, and then see if you have the side that's opposite the right angle given to you in both cases. So for example, this could be, for example, you can see the 90, obviously I'm not going to write down 90 there. If you're given the opposite length as, I don't know, 10 centimeters, say, and here we have the opposite side as 10 centimeters. If you're given one other side, for example, as this side here as maybe 6 centimeters, and this side also 6 centimeters, then what we got? We've got a common right angle there and there. We have a common hypotenuse there and there, and one common other corresponding side. So again, if you end up with this situation, these two triangles are congruent, identical, and they follow the right angle hypotenuse corresponding side rule. Learn them. SSS, ASA, SAS and RHS. They're the 4 rules, and if you know those 4 rules and can apply them in unseen situations, then you'll be fine. You'll be able to do congruency questions. So now I'm going to stop and review the video. There were a couple of stops and starts because the software wasn't responding very well. But anyway, I'll get back to you and I may need to redo some bits and pieces. Okay, see you soon.